welcome to this class on BigQuery done right. When and how, as a healthcare analyst, you should actually be using SQL. Not what is SQL and every bit about how to write it, but when should you actually be using it? What does it mean and represent in our work? It has to start this way. We have to start by putting SQL in its proper place. People, when they learn SQL, have this extreme over-application to try and use it to solve absolutely everything. And that's what this is what that would look like if you've just learned SQL and you think, oh my gosh, I can do so much now, and the new AI tools are going to let me do it instantly. Here's what your life would look like. You absolutely can answer questions from data with SQL, and it is a little bit easier now that there is generative AI. So you can go and use Gemini to write something like this, and you'll get to a query relatively quickly too, so this is a big time saver. You can imagine back before generative AI that you would have to sit and be able to write this out and know everything about SQL and the language in order to get to this result. And then it would be even more inefficient, but trust me, there are people who do this. After that, you'd have an answer. You can get a result, but it looks like this. You've got a table that is sitting somewhere with just that summary piece of only what you asked. So your life will look like this. Write that query somehow, get to an answer, and get a better question. This may be you have a better question, or it may be you provide the answer back to someone, and I promise it will be very unsatisfactory if it's in this format, but you provide the answer back to somebody and you have a better question. And guess what? You're gonna have to go and do the same thing over and over again until the end of time. So I don't recommend that in the slightest. Using it as a way to answer every analytics question is a bit like bringing duct tape into the bathroom. Sure, it'll get the job done, but you're not gonna like how stuck you end up. All right, so where is it the right tool? I believe it is the right tool for building thoughtful data sets. It excels at pulling and organizing raw data from a database, okay? But that's just about it. If from there you get the right tool to do the next thing, you can achieve faster and more consistent answers through interactive dashboards that answer these questions you have about your data, as well as you get the advantage of on-the-fly investigation of your data as well. That comes through data visualization tools. Those are really good at excel at measuring and presenting data aggregated over the fields that are meaningful to you in a way that is flexible and allows you to encode that into a different tool. It's more accessible to others. So you can see that SQL kind of gets relegated up to this one main purpose. I'm going to keep kicking this dead horse because it's important that I make this point. That ad hoc life of, oh, I could answer that. I'll use SQL to ask my database and I can get you to an answer. In order to get that out in front of folks so that they can consume it when they're not technical, you still will have to go through this translation of getting it to a tool and getting it out so that they can get to it. It's nutty and leads to this really messy end product of tons of custom queries presenting information out to end users. It's what I would refer to as technical debt. You've got all of this logic trapped in custom queries sitting in files, and you may or may not be organized and able to keep that in a meaningful way. If instead you use SQL, and guess what? You can still use generative here to do this more quickly, more fully, in a more organized fashion, and use it to get to thoughtful data sets. What you can do is bring those few important thoughtful data sets to Tableau so that as an analyst you can work just with those in order to present forward information. So you get better consolidation, you have more of your output pointing to the same source. It is generally just a far better way to operate, okay? This is work spent thinking about how can this be easier the next time. Instead of, I can accomplish this, I'll go do it, I'll ask the question of my data. It is, how can I continue to answer questions like this in a routine way from the same source and get to some core data assets that are really useful over and over again. So let's go look at what that looks like. You know, it's one thing to say it, but I do want to show you to give you a better sense of what I mean. Now, I am here in the Google Cloud Console, and I'm at our demo hospital system dataset in that healthcare analytics lab environment project. And so I can use from here generative AI to ask questions that I need an answer to from this data set. So I've got that stored over here. Let me just input a question I had written. Something like, I want to find the minimum, maximum, and average turnaround time for patients from their arrival to their procedure start. So this is a fantastic new tool that is going to be able to look at our environment and think about what that question might mean in terms of the data and do its best to produce a query. At first glance, I actually like where it's headed. It's using the OR encounter table. That's what I hoped it would pick up on. And it's just doing a sort of timestamp difference, like a date difference, in order to get to those answers here. And it's looking for only where we have an arrival time and only where we have a procedure start time. So that's going to get out any of our irrelevant records. I think that makes a lot of sense. It's looking over the whole data set. That's fine for how I asked the question. I didn't give it any other parameters. So I think we're good to go. I'm going to say insert, and I'm going to run that. And so this is the answer. You can get to a result that makes sense with a question like that from generative AI and writing a custom SQL query. We have a minimum turnaround of 5 minutes, maximum of 60, and an average there of 31.67. And so this brings you to your next question. Is it different across different groups in my data? Is it different across time? How much time is in my data set? And so that is where each one of those next questions requires a rewrite. So let's say we're going to go ahead and ask this differently. We might go and say, let's edit this, and now say I want to see that by case type. Let's see if it can handle that vague of a question, or if it realizes that I'm asking it to look at this in the way that I just was, and it didn't. It's already looking at, it's going to something sort of vague there. What I probably missed is that I need to highlight this and use this to transform so it has the context that I'm thinking about the query it just wrote, and I want to make this change. So now let's see what are the choices that it made. It's gone ahead and done a group by case type and added case type into the mix for the results. So that's a pretty reasonable choice. I think it made a good decision based on what I asked. Oh, but we have an error. Sorry, I didn't even notice that. Oh, it looks like it should work. Not sure what I did there, but okay. Now we have a different answer based on if the case type was elective or urgent. So the truth is we still can work this way. This is an option, but I think you're going to see quickly that it's not the most efficient option that we have because we have tools like Tableau. So I'm in Tableau Public, and I've loaded this same table. I have already made one new addition here, which is the main kind of like extra work that I'll have to do in Tableau is I have to define what is that turnaround time that I'm talking about. So that wasn't automatic. I had to go and create this field, which is taking the date difference between arrival and procedure start. So that's extra work. Generative AI isn't allowing us to do that yet. In fact, it probably does if you have Tableau and their AI agent, but anyway, the point is still there. I can take a tool like this and a measure like this, and I can bring it out onto the Tableau and go ahead and change this measure to the minimum first. We get the answer to be 5. And actually, let me do something and pull this out in a different way so I can now bring it back to add this in. And I'll do this and take the maximum, 60. So you're seeing we get the same answer as that query before. Let me pull it again over here to the measure value. And let me take this and do the average, that 31.68. So now we are at the same exact result as we had from that query in a not that different amount of time. Here is where the efficiency comes. Instead of having to rewrite the query, check and see if it made good choices, we can answer the question that we had before, which is this different across different case types, very quickly by keeping the measures that we are working with out here and adding case type as one of the rows. So now I've got that same information, but guess what? I've got it together and split. And after I get done answering my question about is it very different across case type, which I would say the answer is not very much, let me add a total column so that I've got a comparison to the total of 31. Got it. Elective cases are a little bit longer and our urgent cases are a little bit less. Interesting. So let's go from that to, okay, case type is answered. I want to see if it's different across the different operating teams. So I'll replace case type with operating teams, and I have my answer. I can go ahead and change that into procedure name. Oh, that's not a drop, sorry. Put it on the pill. There. Now I've got it by procedure name. Now I might take it by operating team and procedure name. And now I've got an answer to this same question, all three of the next interesting questions to me in a matter of seconds. And that's just in table format. And of course, we could evolve into visuals from there. So that is how this tooling is more efficient at flexibly answering questions about our metrics across different dimensions we care about in our data. And to that point I made earlier that, oh, we may actually be interested in what does this look like over time. Let's simplify this just a little bit to look at just the average arrival time. And let's bring out the arrival date time, and I'm going to do by month and year and turn this into a line graph that would make some sense. There we go. So now we are very quickly, which you absolutely can't achieve in SQL, looking at a visual of this average turnaround time over time in our data set. We've learned a couple things instantly. We have data from January to December of 2024, and it looks like there is actually an increase in this turnaround time over time. So that is the role that this different tooling plays, and why I make the case that getting to your good summary data for SQL is the best place to use it and where it should sort of just be kept. It's always there to do ad hoc things when you need to, but that's what needs to be done. But that raises a good question. What does a thoughtful data set in healthcare look like? Because you may think, oh my gosh, there are thousands of these types of data sets. I think it's simpler than that. I'm going to make the case for what I believe is the path forward to understand what type of data is needed and how to do that. So, first of all, I'm going to put forward a better IT delivery pathway. I think a better pathway for using SQL and IT to deliver what we need is to use SQL to deliver denormalized data building blocks. Those can be used for analysts to mix and match the different building blocks to answer the questions that they have and pull in just the building blocks they need as they need them. That allows them to do these custom dashboards from some core data assets. That is a good way to deliver better by driving top priority questions into these analyst-ready building blocks so that analysts have what they need to define and trace and aggregate their metrics across any dimension that is meaningful within the data set. This really helps in building reusability into our work. So, what do you need to do that? You need to start by building from the ground up. I'm talking about data sets need to be analyst ready with data at the right level of measurement. That is the right core rawest piece of information that's needed, such as the encounter. I need everything at the level of this one encounter in the hospital, or the individual patient when that's the relevant unit of analysis. Sometimes we're deeper than that. Sometimes we're looking at something like the individual order. And so I need the data to be sitting at that level in order to provide information about each order. And so it depends on the topic that's being covered. But I'm going to show in more detail the topics that I think are relevant and how to set these up in a couple of different core types of tables. But let's keep going on this idea. In general, I'm trying to share that you can give control to your analysts by doing a good job of getting them data sets that include these three elements. Fields that define the measure. So do they have the what do I count, right? Do they have a unique identifier for each unit that they are trying to count? Fields to define the population. When they have to answer questions about only patients of this type, only patients during this time, only patients that arrived at this location, they must have those elements in the data set so they can use them quickly to scope down just to the population they want or to describe the answers across different populations. Next, they need the fields to aggregate to operationally relevant levels. So this is what geographies, what teams did the work, what was going on with the patient in something like their level of care. If they have those three things, this is what it enables. It enables analysts to traverse the entire space from the entire system-wide metric, like what is total length of stay for our hospital, down to the exact patient encounter that created them. So you've got the ability to give this answer for the whole institution, scoped appropriately because of number 2 in our list. Or you can go ahead and dissect that down into the units, the teams, the disease categories, the origin, the payer, so on and so forth that we need in order to make this relevant to operations. And at the very bottom, we can go down to the individual record that created this information. This is absolutely key and necessary in order to trace what is changing in our metrics all the way down to the individual records that create that change. So, building from the ground up is those fields to define the measures. What I'm talking about here is things like unique identifiers so that I can count appropriately. Numerical measures like what was the length of stay on this encounter? What is the age of this patient? Those sorts of things. Next, in fields to define the population, I'm talking about some of the common things you would hear in healthcare, like a patient class or an admission status. Things like dates, admission date and time, discharge date and time. And finally, that third category, the fields to aggregate to operationally relevant levels, are going to be the things like departments or care teams or level of care that we group in order to describe our population in different manners. All right, so these reusable building blocks are something that can be accomplished with SQL. The challenge that we're trying to solve for is that new analysts often embed all their filtering, joining, and logic into one-off pulls of the data. In the past, that might be one-off manipulation of the data in Excel. And as the skill sets evolve, that is one-off SQL queries that are hidden, who knows, on someone's local machine. Maybe it's in a shared environment, but it's buried in code. So this solutioning to common data assets is used to help solve that challenge by defining a small set of standardized data sets that we use our visualization tools to point to and accomplish the aggregation and measurement of what we actually care to measure. So there will be 4 core data table types that I will put forward here that I believe are universal to wherever you work in healthcare. The first is a summary record. So this, what you summarize, will change depending on where you're at. You may be summarizing claims. You may be summarizing hospital encounters. You may be summarizing some sort of device input. But what you need is one row per that relevant unit of measurement, okay? In my world, that is the inpatient stay or an encounter. So I need a summary of the encounter, a simple table that has one record per encounter. So I don't get messed up on the level of the record. I've got a summary of what happened for the encounter, and there's just one row that will tell me that. After that, I have a type of table called care detail. This is where I've got multiple rows per encounter, multiple pieces per claim, multiple pieces per X, Y, and Z. These are things like meds, labs, delays, events. This is where you get into the nuanced nitty-gritty of what happened during the summary record, right? And so it's here in its individual pieces so that it can be added in to use with the summary record, but only when needed. It doesn't have to be there every time because this complicates our life. This makes our record much longer, much bigger often, and we don't always need it. So we keep it in its own separate table type, ready to connect to the summary and use when the question is about labs or about meds or has some piece about delays we need to answer. So that's table type number 2. The third is really the core. These three things together are the core. The last one you'll see is sort of a different use of the data, sort of more logical. But summary, care detail, and the last thing is dimension detail. So this is going to be the descriptors that you often need, like about a patient or about a provider, about a location, about a department that slowly changes over time, right? A patient has an address today, and during the course of how long you care for them, hopefully a lifetime, you can see that they'll need to change that address. They'll need to change different elements that we pull and ask about them. Providers have a department today, but they may not stay in the same department forever. They may have a specialty today, but they're in training. That may be another dimension, is what kind of training they're in. And so we need this sort of detail captured and kept so we can point to it and answer at this point in time, what was this detail about this provider or this detail about this patient? So it's another really key core data table type that we need. Now, this is all available in the data set that we have, and we're going to look at examples of that next. The last one is one that I think is quite essential, but there are different ways this can be accomplished. I'm going to put forward one of them that is useful, but there's more than one way to accomplish this. So it's not this is the only answer. I think this is a understandable answer and a great way to get introduced to the idea. That is to do a time spread of information. So picking a granularity that's meaningful, like the hour, in order to capture and see what's going on in this example across the inpatient stay. So for every hour that they were here, what was happening? What department were they in? What level of care did they have? What meds were they on? Did they have any delays? That sort of information kept at the hourly granularity. So we're going to go now look at some examples of these so you can see a little more what I mean. The summary table, I'm going to talk first about inpatient stays. Inpatient stays have all sorts of different activity that happen within them, but summarizing key factors for these stays is really, really meaningful for getting to the quick answer on how many, where, all the core comes from this. These data sets often, for me, answer 80% of the questions. Most of the common questions I have about in my day-to-day or my analyst covered day-to-day are covered by this sort of simple summary table. An example of this in the data set that I've built for us in Google BigQuery is the HSP encounter table. So this is a record that has one row for every hospital encounter, and it's got some common summary information there. You're seeing in the example below, the CSN is the unique identifier. We have an admission date time, discharge date time, what was the DRG, MDC, and origin group as an example. So this is a way that we can have a piece of data that quickly allows us to answer questions like how many of these hospital encounters happened within this time period or with this DRG. with this origin group. You're seeing above the simple query that could pull this information from that data set. So you could take this in practice, go ahead and pull on this data and see what it looks like for yourself. I'm going to highly recommend a step like that. You don't have to borrow my query. You could also come here to the data set, and next to HSP encounter, if you choose the ellipses to the right of it and choose query, it's going to build a little starter query for you. And a great new resource that has come into BigQuery is this reference area on the right-hand side. You're going to see that it's got HSP encounter up for me, and it has all of the fields that are in it. And so that can help me build my query by keeping your cursor in the select statement. First, I'm going to start by organizing it. Put the from statement below. I'm going to get rid of this limit. And here in the select statement, I can click on the column names to the right, and it will insert what columns I want to pull. So let's just grab everything. Now you see that it builds the select statement with a comma between each of these, and it's ready for me to run. And so now you're looking at an answer to what is in this table. It is one record per encounter. The unique identifier is this CSN, and all we know is the DRG, the MDC, the origin group, and admission and discharge. So that is what is in a summary record. Next, let's talk about care detail. These are data sets focused on specific events, types, activity, work that's done during the patient stay. They're often there for the ability to see what happened over time. These details are available for use just when necessary, not always. So we keep the summary record simple and with the core elements that we need, but when the next question comes, we can go to one of these detailed questions. An order is an example of care detail. So this table in the data set includes one record for every order. There's a unique identifier for it with that order ID. And there's details about what was this order, what patient was it for through the patient ID, what was the ordering provider, when was it placed, and when was it completed, as an example that you're seeing in front of you. So these can be mini records per encounter and can kind of complicate the picture that we're looking at. So we keep it in its own table to bring into play when we need to use it. So we may answer a question about what orders were done, how many orders were done, how many orders per patient, how many orders per encounter, those sorts of things. That's the other flavor after summary is care detail. Next, I'm going to look at a slowly changing dimension, these dimension details tables that are so necessary. It captures slowly changing attributes, things like a department care team category, patient's address, physician titles, so on and so forth. On the right-hand side, you're seeing visibly an example of address that has changed, right? And so this is a typical implementation pattern of these sorts of tables where you've got a surrogate key that's created by this record. And the natural key is something like the customer or the patient. And so you're seeing that there are two records here that are both the same natural key, both the same customer, sort of in this example. And then you get the attribute that you care about, in this case, an address. And you see that there have been more than one address for this customer. What helps us see when this attribute is relevant is an effective start and an effective end. Now, the first record is showing us something that was in place from January of 2018 through June 30th of 2019. So that anything we're looking at relative to this customer during that time period, that's the right address to use for them. But the next record down starts on 7/1 of 2019. And after that time, we've got a different address. Now you may say, until when? And the effective end date is wild, right? The year 9,999. That is just a placeholder to indicate that that is the current information. So until something new comes in, this should always be used. And appropriately, the current flag is set. So this is how this data is typically stored and kept. So you have access to be able to answer what is a patient's address, but more specifically, you can answer either what is a patient's address right now, or what is a patient's address as of a specific point in time. So this is another really common need in healthcare and how this data should be kept. An example in our data set is the DIM patient. You will see here that we've got an example showing you. You can see in rows 2 through 5, we actually have the same patient. And what is in place is a different address. You see that patient zip code is changing in each one of those records, and there's a different effective date and obsolete date on each of those. So there's a patient that is moving all over the place. But this is an example you have to go and work with and play with in the data set I've built into BigQuery. Next is a time spread data set. So I'm going to show you an example I think is useful, but there are multiple ways to accomplish this. I'm going to put this at the hourly granularity, and it helps to address the majority in my world of time-specific questions. So it's expanding a hospital stay into hourly records that offers the detail of what was true at that individual point in time. So that approach helps to enable us to understand what was happening at any given time across all patients, or what's happening for an individual patient across all the time that they were here. And so just visually to get an idea of this, I'll show you an example. But first, we won't go in detail as to how to create this, but it is straightforward. I personally think you can get there very quickly with generative AI nowadays. The only prerequisite you need is some table that has a play-by-play of all the things that happened or changed for a unit, for a patient, for an encounter, as an example, with a timestamp. From there, SQL is a fantastic tool. It's very capable, especially generative AI will help you write the query that would get you to an hourly record of patient dimensions. And you can use some of our other classes here that talk about how to use generative AI to do effective text to SQL or talking to SQL code, and to verify you got a good result, and specify your goal, and put all of that information in a way that you're going to get to a good end result and trust it. But I just wanted to point out, this is something that's you absolutely can accomplish through SQL, and your prerequisite is just going to be that play-by-play information of what changed and when, the relevant details that you want infused. So here in front of you is an example I put together of that hourly level of detail. And I'm going to trace it back to this idea I put together on the 3 things we need in a data set. And that is that we need fields to define the measure. And so often in time-based questions, we're answering the how many and when types of questions. So you're seeing that I've highlighted the date, the hour, and the encounter. Now this is what represents a unique record in this data set. So you're seeing at the very top on January 1st of 25 at midnight for this encounter number 592, we have something going on, and their information continues through the rest of the hours of that day and presumably probably beyond, but I'm just making it so you can see it. Then I show you a secondary encounter that's included that is also on January 1st of 2025 at midnight, but this encounter is encounter 823. So this allows us to be able to say what was going on at midnight on January 1st of 2025, and to count up, as an example, how many encounters were here in the system, or on the department, or at this department level of care, or anything else that's in the data set. And so that is the fields. Actually, that's the next point I want to make. So I'll pause and just use my bullet point to share what was intended to be next to share, which is in the data set we need the fields to define the population. Those are going to be things like patient class, patient level of care. It's descriptors of the patients or the situation that you would use to filter down or sort just to what you care about, so that you can answer questions like, how many people were here how many encounters were present that had an emergency class, a patient class rather, of X, or that had a patient level of care of X. So that is the type of field needed in a data set in order to scope down to the population you care about before you do the last item, which I had jumped the gun on before. The last item is to aggregate to an operationally relevant level. These are the pieces of data that are needed, so we may tell everything that was going on at a point in time for a specific department or for a level of care of department. So these are the fields that are going to allow us to accomplish what we need to describe what was going on at a point in time across these different dimensions with the data set, and how it kind of maps back to the concept I was pointing out. The things needed in these data sets for our analysts are fields to define the measure, fields to define the population, and fields to aggregate to operationally relevant levels. So let's come back to this list of what are the core data types. What are the thoughtful data types, data sets that you need to create with SQL before you are ready to effectively use visualization tools. Those core data sets are a summary table or multiple summary tables about units of measurement that matter to you. So in my example, I've been given a lot of examples like the inpatient stay encounter, and our data set reflects that. So those are the main summary tables we have. Then care details. This is going to be multiple records per encounter and encapsulating activity like labs, meds, orders, delays, events. After that, you need some way to track and know what was true about different elements in your data over time. This is slowly changing dimensions. Things like patient information, provider information, or descriptors of geographies or locations in your system. And finally, I find it very helpful to also have a time spread piece of information that is sharing the what was true when. So that one record per your summary unit per time period that's relevant, such as hourly in the example that we just looked at. So that's the proper way to use SQL in healthcare, is to build those thoughtful data sets so that you can move on to use the right tool for faster and more consistent answers through things like interactive dashboards that answer those questions or on-the-fly investigation with common core data sets. And that is really the work of data visualization tools, not SQL. So that is what I would give you for where does SQL play into the life of an analyst. Just for full transparency, in my team, I'm the one building and using SQL to deliver core thoughtful data sets to my analysts who are working in data visualization tools. So this pipeline can often be split up between different roles and different people. I'm just sharing how it's done on my team. That is not the only way that it's done for sure. And you're in this class because you're interested in some advanced analytics. And the case I would make is that you can become a real unicorn, a very versatile person by learning SQL so that you can be effective at that top end of the pipeline and be an absolutely invaluable player in accessing data through all the way to visualizing, using, and presenting it. So that's why I think you should be learning SQL, but I want to make sure that you're keeping it in its proper place to build thoughtful data sets from the raw data. Thanks for tuning in. Thanks for sticking with me. Excited to keep sharing about this advanced analytics in healthcare.